Alright guys, so today we are talking about factoring. So normally we were just factoring things with x squared in them. Now we're going to factor with higher powers than x squared sometimes, not all the time still. So the first type of factoring that we talked about was greatest common factor factoring, right? So in this first problem here, you can see that 12a cubed plus 10a squared. Well, 2 would come out of both 12 and 10, and we could also pull out an a squared out of both of these terms. So when we factor that out, it's like dividing each term by 2a squared. And what that does is it moves the 2a squared to the front, and then what's left is 6a plus 5. All right, and then that would be as much as we could factor that. For this next one, we just need to look at what's the biggest thing that comes out of each term. So 7 comes out of both of those. So we put 7 up front. We have m to the 8 and m squared. So we can actually pull out an m squared out of both of those. And then we have n squared n to the 5th. So we can pull out an n squared out of both of those things as well. So what that's going to look like is it's going to take both of these and divide it by 7m squared n squared. Divided by 7m squared n squared. And then that is going to give us 2. 8 minus 2 gives us m to the 6th power, n to the 5th. So 5 minus 2 gives us n to the 3rd power. And then 7, 7, m squared, n squared. So that's just going to be minus 1 because everything canceled. And then this would be our answer. Okay. All right, next up we have difference of squares factoring. Again, you guys know your difference of squares. We've done this a billion times, right? But let's just think about some perfect squares. So perfect squares would be like 4, 9, 16, and so forth, right? But you can also think about variables that are perfect squares, like x squared is a perfect square, or x to the 4th is a perfect square, or x to the 6th power is even a perfect square, right? This would be x times x to the 4th would be x squared times x squared, x to the 6th would be x to the 3rd times x to the 3rd. So those would also be perfect squares. Any even power is technically a perfect square. So the rule for difference of squares is going to be a plus b multiplied times b minus a. And we know that, right? We took the square root of the first term, square root of the second term. That gave us x and 3. And then we just filled that in. So x plus 3, x minus 3. And that would be how we factored difference of squares. And it doesn't change here. Okay, so we have 64x squared and 49. Square root that, we get 8x. Square root the back, we get 7. So that's 8x plus 7 and 8x minus 7. Working down a little bit lower, so right here to number 5, you can see that we have 7 is not a perfect square. So in order to first do this question, we need to take that 7 out so that we actually can get a perfect square. So that's 7 factored to the front, x squared minus 4. Now we have a difference of squares, right? So that's going to be 7, x plus 2, x minus 2. And you have to make sure you keep that 7 in there because it's the greatest common factor that got pulled out at the beginning. All right, let's take a look at this one. Again, not a difference of squares yet, but hopefully by pulling out a greatest common factor, we can find a difference of squares. N is the biggest n we could pull out. M is the biggest m we can pull out, and then we can pull out 7 again. So 7mn is going to give us m to the 6th power minus 4n squared, right? Because we're dividing this by n, dividing that by m, dividing that by 7, yeah. So 4n squared. If you're struggling with that, think about your exponent rules, right? 7m to the 7th over n divided by 7mn. 7 minus 1 is going to give us m to the 6th. 7's canceled, m's cancel. So m to the 7 minus 1 is m to the 6th, right? That's how we got this one. And then 28mn cubed divided by 7mn, right? 3 minus 1 gives you 2. So there's our n squared. M's cancel. 28 and 7 give you 4. All right. Now that we have our difference of squares, we just need to factor that, right? So square root both, that's going to be m cubed 2n, so 7mn, n cubed plus 2n, n cubed minus 2n. Sorry, this should be an m in front, m cubed. Okay, that's our difference of squares. Again, not much has changed there. Sum of cubes. So our perfect cubes, you could think of 1 is a perfect cube, right? 2 times 2 times 2 is 8 is a perfect cube. 27 is a perfect cube. And then we need to think about our variables as well. So x cubed, x to the 6th power, x to the 9th power. Any power divisible by 3 is going to be a perfect cube. The rule for sum of cubes, this is kind of difficult, okay? But here's the rule. It goes a, and then plus b, and then a squared minus ab plus b squared, okay? This second part can never be factored, okay? It's always going to make imaginary numbers, so you never need to worry about factoring this second part again. How do you memorize that, right? Because there's a lot going on there. It's actually, we like to say in math, always use SOAP. So S stands for the same sign. O stands for the opposite sign. A stands for always. And P stands for positive. So there's our SOAP. And as you can see, because it's the sum of cubes, we have our same sign, which is positive, the opposite sign, which is negative, and then the always positive at the end. Okay? So let's actually factor one of these behemoths. So how do we even get a and b? Well, we just take the cube root of both of these. Okay, so the cube root of x cubed, so that tells us our a is just x. Our b is going to be 3. And now we're just filling this in. It could be helpful to have an a squared, an ab, and a b squared, so why not? A squared would be x squared. A times b would be 3x, and then b squared is going to be 9. So now we have all the tools to just fill in the rule. So we have x plus 3 multiplied by x squared minus 3x plus 9. And that's all there is to it. As soon as you know AB, as long as you know SOAP, you can just fill in the rule. Okay? So let's do the same thing here. Our A value is going to be m, right? The cube root of this backside will be our B value. So cube root there is going to be 4n. So that means A squared is m squared. B squared is going to be 16n squared, and then A times B is 4mn, or 4nm, doesn't matter. Just as long as you multiply A and B together. So then if we're going through this, we know A and B goes in front, so m and 4n. It's a sum of cubes, so same sign means plus. Now we have our A squared, so that's m squared. Now we have the opposite sign, so minus, and then AB is next, so 4mn. And then always positive, so plus sign, and then our B squared goes on the end, so 16n squared. And there's our sum of cubes again. All right, let's take a look at number 9. Number 9, our A value, we got 2m, B value 3n. So that means A squared is 4m squared, B squared is 9n squared, and AB is going to be 6mn. Again, filling out the rule, A and B always come first, whether it's sum of cubes, and we're about to talk about difference of cubes, but AB always comes first. So 2m and 3n. Same sign would be plus. Now we have A squared, which is 4m squared. Opposite sign is minus. AB is 6mn. And then our B squared which has always positive on it, is going to be 9n squared. And then there's our solution. All right, last one. So 5 is not a perfect cube. So what we're going to have to do is we're going to have to divide 5 out of here, or factor it out. So that's going to be 5x cubed plus 125y cubed. So now our a is x, our b is 5y. So let's just fill it in from there. So we have a and b go first. Whoops, can't forget the 5. Okay, so 5 is in the front. A is x, b is 5y. It's a plus sign there because the sign always matches, SOAP. So same sign. And then a squared is going to be x squared. Now we opposite sign, so minus. And then ab is 5xy, always positive. And then at the end is 25y squared. And that would be our sum of cubes factoring. All right, difference of cubes. Okay, same perfect cubes, right? 1, we got 8, we got 27, we got 64, we got 125 after that. The rule is so close to the sum of cubes. Here we're going a minus b, hence same sign, a squared plus opposite sign, ab, and then always positive, so plus b squared. Okay, so the a's and b's don't change at all, it's just the signs. And so SOAP still applies for our difference of cubes. So let's take a look at it. We have the cube root of 3 and the cube root of 1, so that's a is x, b is 1. So then let's fill in from there. X minus 1 times x squared plus x this time because it is the same sign, and then always positive, so plus 1 at the end as well. Next one here is 216k cubed minus 125. So 216 is our 6 cube rooted. So that's going to be a is 6k, b is 5. So that's 6k minus 5. So 36k squared. And then we have opposite sign, so plus. AB would be 6 times 5, which is 30k. And then always positive, so plus, and then 25. And this is just something you're going to have to memorize. And if you memorize SOAP, the rest should come pretty natural. All right, next one. So this next one, 4 is not a perfect cube, so we're going to have to do some greatest common factoring. So divide by 4. 4 gives you 1 minus 8x cubed. So that tells us a is 1, b is 2x. So we put that 4 out front. So 4, and then a minus b because we're doing difference. So that's 1 minus 2x. Now we go a squared, which is 1. Opposite sign is positive to the first one. So plus 2x, and then always positive at the end, tells us 4 plus 4x squared. All right, last one. So again, we're going to have to divide by 2 here. That's going to give us 2x cubed minus, what is 27y cubed, right? So then a is equal to x, b is equal to 3y. And now we just fill it in. So a minus b, which would be x minus 3y. A squared would be x squared plus ab is 3xy. Always positive, so plus b squared, which would be 9y squared. And there's your answer. Okay, so again, difference of cubes, that's just going to have to be a memorized rule. Okay, and if you memorize SOAP, that should be good enough because after that, all the variables follow the same. It's a squared, ab, b squared every time. All right, next on the chopping block, we have trinomials. Okay, trinomial factoring, nothing changes. This time we just might have to factor in a couple more steps than just one step. All right, so for our trinomial factoring, we need to figure out, well, what goes n to the fourth power, right? So if we break this up into its two factors, just as if we were doing n squared, right? But now we would say n squared times n squared would give us n to the fourth, okay? Factors of 24 are 1 and 24, 2 and 12, 3 and, is that 6? No, 3 and 8, and then 4 and 6. We need 2 in the middle. Signs are opposite, so plus and minus because of that minus sign at the end. And then it looks like a positive 6 and a negative 4 would make positive 2, which is great, right? But now that we've got here, as you can see, a difference of squares pops up. So now we need to go n squared plus 6. Can't factor that, but we can factor into n minus 2, n plus 2. So now we're trinomial factoring very similarly to what we did in the past, but it might have to go a step further. Let's check out this next one. So here is one where we're going to have to pull greatest common factor out first. So x, that's going to give us x squared plus x minus 20. I knew you were going to have to pull out this x because the only way to do trinomial factoring is if the first power, or the biggest power, is an even number. So I knew I was going to have to divide it by x to make it an even power. So then we have x, 20, we need 1 in the middle. That's going to be 5 and 4 for sure. So x plus 5, x minus 4. And there's our factors. Okay, next up, gonna have to pull an a out of here. It looks like we'll also have to pull a 2 out of everything. So that's 2a is out front. It's gonna leave us with a squared plus, that is that 19a? Yeah, and then plus 34 for the last term. And then let's figure out these factors. So that's 2a. So we're gonna have a and a. They're both plus. So we need to get to 19. So 34 is going to be 2 and 17, which that looks like it works. So we should have 2 and 17. And then there's all of our factoring. Alrighty. X to the fourth power. So that's going to tell us x squared and x squared. Minus at the end tells us plus and minus. And then it's 25 with 24 in the middle. So it's looking like negative 24. And then a positive, negative 25, my bad. And then a positive 1 is going to make that negative 24. Here we can factor a difference of squares once again, so x squared plus 1. That gives us x plus 5, x minus 5. And then there's our answer. Change up the color here. Continuing down, we have 3x to the fourth in the front, x to the fourth. So that means we have 3x squared and x squared. Negative in the back tells us plus and minus. We need 14, so we got 1 and 5 is the only option. It's looking like 5 times 3 would give us positive 15. So if we did that, and then we subtracted 1 off of it, right? So this is 15x squared minus x squared, which would make positive 14x squared. So that's solid. We double check, is this a difference of squares? So 3 is not a perfect square, so it's not. And then is our other one? Also not a difference of squares. So it looks like 3x squared minus 1 times x squared plus 5 is our final answer right here. I'm just going to highlight it. All right, last one here. M to the 6th. So now we have 3 and 3, or 1 and 9. In the back, we have 1 and 4, 2 and 2. So we're going to have to do some thinking here. We need negative 12 in the middle. We have positive at the end. So that tells us at least one thing about this. The one thing we know is that it's negative negative, because positive at the end and negative in the middle means they're both negative. We need 12. So 2 times 3 is 6. Well, if we just do that twice, so 3m to the third. 3m to the third, because if you multiplied these two, it would give you 9m to the sixth. And then that's going to be 2m and 2m. Right, so let's check this. That's 6m to the fourth power, negative 6m to the fourth power as well. So that's good. That's perfect for us. So that makes negative 12 to the 4m. Actually, was not thinking here. We could have pulled out that m squared in the first one. So here we would pull out an m, right? Because both of these are divisible by m. And then we pull m out of this as well, which would move m times m to the front, and then it's 3m minus 2, 3m minus 2, and this just becomes an m squared. So that's my bad. I wasn't thinking greatest common factor right off the bat there, but we still do need to pull out the greatest common factor at the end there, which was those m's. Okay? If you have questions about that last thing that I did right there, please feel free to ask me in class. Okay, last type of factoring. I know we've done a whole lot of factoring so far today, but there's one more to go, okay, and it's called factor by grouping. And here are the steps right here. It says group the first two terms together and then group the last two terms. So I like to do this. So group these two and then group these two. It says factor the greatest common factor out of each group. So in the first group, we have x squared can get pulled out of both of those. So that's going to be x squared, x plus 1. Greatest common factor in the second group, we need this to match. We need this to be an x plus 1. So we need to pull out negative 4 out of both of those things. So if we pull negative 4 out, that gives us x plus 1. Okay, so we factor the greatest common factor out of each group. Now it says factor the common binomial. So what that means is we're going to factor this x plus 1 out of each of those. Okay, so what does that look like? An x plus 1 then moves to the front, and then the only thing left is going to be x squared minus 4. All right, so to think about how that works, think of our x squared as a, and then think of x plus 1 as b. If you think of 4 as c, x plus 1 is still b. What we did was we factored b out of both of those, so it became b times a minus c, right? So here's our a minus c, and then here's our b. And that's how the factoring works. So, since the factoring works like that, as you can see, we still have a difference of squares, so we got to factor one more step, so that's x plus 1, x plus 2, x minus 2. And there we go. Factor by grouping. So let's take a look at that again. Number 21, we group the first two terms together. X squared is the biggest thing that comes out. What's left is x minus 1. We need this to be x minus 1. So if we divide both of those by just positive 9, so positive 9 comes out. It's x minus 1 as well. And then we factor the x minus 1 to the front. So now we have x minus 1. And then it's x squared plus 9 is left. Not factorable, not factorable. So then our solution is right here. Same idea. Group the front. K squared comes out, so we get k plus 5. We need k plus 5 out of that, so I'm thinking negative 1 gives us k plus 5 here. Now we factor the k plus 5 out of both of those terms, so k plus 5. And what would be left would be k squared minus 1. K squared minus 1 is a difference of squares. So we go k plus 5, k plus 1, k minus 1. And there's all of our factors. Okay, you guys are doing great. I know it's a long notes, but these are our last two. And I just wanted to make sure to show you every example so that you could see them all. Here we're pulling out a v squared, and that's all that can be pulled out. So that's 4v minus 5. In this one we need positive, so we're going to have to pull out a negative 4, and that should be it. So that gives us positive 4v minus 5. Yep, there we go. So 4v minus 5 to the front, v squared minus 4 to the back. So 4v minus 5, v plus 2, v minus 2. Bam. All right, last one. Looks like we pull out a 2x to the 4th power. 2x to the 4th gives us x minus 9. Then we need to pull out 7, so plus 7, x minus 9. So that is going to be x minus 9 to the front, 2x to the 4th plus 7 in the back. Okay? This is not a difference of squares. It's not a sum of cubes, difference of cubes. So then we are going to stop right there. All right. So that is going to be that for the notes today. As always, if you have questions, feel free to message me on Canvas and let me know. Have a great day.